Yeah, so my name is Igor Dubinskiy. I'm a software engineer at a company called GoGuardian. We build software for schools to help them get the most out of technology for their students. We use a lot of GoGuardian, and we're hiring, so check us out. The title of my talk is Iteratively Migrating an HTTP Service to Go and gRPC using gRPC Gateway and HTTP util.reverse proxy. It's a very literal name, it's very long. A better name might have been not sure if HTTP service or gRPC behind gRPC gateway. For those of you that have been going to GopherCon for a couple of years, or even this year, you probably heard gRPC. You might have even used it. It's really cool. Sean did a talk earlier today, a lightning talk about it, so I'd encourage you all to check that out. But some of the main benefits of that are strongly typed request response message types. You can generate code for clients and servers, and you can use protobuf is the wire format, so it's a lot more efficient than stuff like JSON XML. And so we've started to use gRPC a lot at GoGuardian for our services, but one big problem is if you need browsers to talk to a service that uses gRPC, in which case you need something like gRPC Gateway, which will serialize HTTP requests, the path, the method, the request body, query parameters into a RPC response, proxy that to a gRPC server. I'm sorry, RPC request, proxy that to a gRPC server, and then back out as from the gRPC response to the JSON response body in HTTP. And it's cool, you can also generate Swagger docs from it. So we've had a lot of success using that for services in migrating them to gRPC and gRPC Gateway for browsers, internal services, things like that. So when we're migrating a service from HTTP to gRPC, we have a few options. If you're using anything but the browser, there's one pretty quick option you can use, pretty robust, which is to modify the clients to use gRPC. That gives you the best performance and static type safety, a lot of cool features. If for whatever reason you can't or don't want to do that, then you use gRPC Gateway. So if you're using the browser, if you're using maybe some legacy systems you don't want to modify to use gRPC, here are a few options for that. You can modify the clients to call each new method as it's implemented in the new service. So that's nice because it's an iterative approach, but it means that you're changing a lot of places in the client code. You can also modify clients to use the new service once you've implemented all the routes in the new service. The issue with that, though, is you kind of have to wait until all the RPCs are implemented in the new service, which could take some time. And if you're doing a cutover all at once, that might lead to some issues and bugs that you have to iron out. So we came up with a different method that lets you combine the best of both worlds. And that is that you can use the new service to proxy unimplemented routes to the existing service. So you make the change once to point your client services to the new service, and then the new service decides, hey, do I have this route? If I do, then I can serve it directly. Otherwise, I will just proxy to the old service. And the way that works is you create a reverse proxy using the really useful HTTP util in the standard library with the old service URL. And then the gRPC runtime has an other error handler function that you can override. And so first we check if it's a status not found or status method not allowed, which tells us this is something that gRPC Gateway wasn't able to find in our implementation. If it's not, then we let the default error handler handle it. Otherwise, we just proxy it over to the old service. An example of this is on GitHub. And time for a little demo. So on the top left here, I have a Node.js service running on port 8000. And then I have a Go service running that's got a gRPC server and an HTTP server with gRPC Gateway. That's on port 9000. So what happens if I call the Node service on this endpoint? I get this get response with this hello world, and we can see that it's coming from Node. We added this header. If I hit it on port 9000, which is Go, you can see that same thing, same response. That came from Go, and you can see in both cases they log that they got a request. So now what if I do the post request? I make a post request to the node server on port 8000, and that comes back with the source server's node. and we see the log here, we see the hello Gopher message. If we do the same thing, but port 9000 for Go, what we see here is we got the request, but then that's not implemented currently, so we proxy that. Now that goes over here, and we get the same hello Gopher response, and the source server is Node. So now we want to implement this, this new endpoint, so we'll go to our protobuf file, we will add this service definition, or this RPC definition, and then we will implement that in our code. We will generate the protobuf and gRPC gateway code for that, and then we will run the server again. Now, if we make that exact same request, we'll see we got it directly, no proxying, and the source server is Go. So we've just implemented a new server and not had to touch the old Node server. So that way you can just implement routes in the new server, and it'll transparently proxy to the old server until it's implemented, and then it'll use itself once you've implemented it. Thank you.